Hey, what is up, you guys? Guys, welcome to another episode with the one and only Incredible Academic on the Incredible Academics YouTube channel. Guys, I hope you're all excited. I am super excited to be doing this episode with you. So, today we are going to still be looking at the proofs for sine, cosine, and an area rule. Okay, so this is what we're going to be looking at: sine, cosine, and area rule. Right? It's just that now this time around, the triangle is going to be looking slight differently, right? This is the triangle that we're going to attempt to prove. So this is this vertex here, we will call it A, this will call it B, and that will call it B. All right, so that's that. And obviously there's a couple of constructions that we need to put in place in order for us to be able to prove. Okay, and let's just start with proving cosine, which is arguably the most difficult to prove. So we're going to construct this vertex over here, and I think it would be appropriate for us to label it D. So this will call D, right? So obviously if that is C, this needs to be little c. If this is B, this needs to be little b. And if this is A, that needs to be little a. All right. And we'll label the side BD X. Okay. And obviously the perpendicular height, that's just going to be our H. So how do we prove? Remember, you must be thinking, you must be able to identify the two triangles that we're looking at. Okay, there's always two triangles after you've done your constructions and everything. So we're proving cosine now. Cosine rule. Right. So this is the diagram that we're going to keep on referring to when proving cosine. So yes, let's go right into it. So in the first triangle, right, in the first triangle, as you guys can see, triangle 1, so basically we are going to operate in two triangles, right? We are going to operate in two triangles, and we're going to try to operate in the two triangles that H belongs to. You can see that triangle 1 doesn't have H as one of its sides, so we're not really going to be operating in that triangle. But if you check triangle ACD, right? Triangle ACD does have H as part of its as one of the sides, right? And if you check triangle BCD also has H as part of as one of its sides. So what we're going to do is we're going to focus on ACD and BCD, simply because they've got H as one of the sides. So now let's express the Pythagoras theorem. All right, starting with the triangle ACD followed by the triangle BCD, which is triangle 2, right? So you can see that obviously triangle ACD does have a right angle triangle. In other words, now we can actually use Pythagoras theorem within that triangle. But B within ACD is the what we call the hypotenuse. Okay, so we know that b squared is going to be equal to 8 squared, right, plus, remember, if this is c and that is x, the whole of AD is going to be the sum of c and d. Do you understand? So meaning that we're going to have what? X plus c over there squared. All right, and you need to indicate that this is Pythagoras. All right, and then also we are going to have, now that we're done with ACD, we're going to focus on the on triangle 2. Okay, so in triangle 2 we know that a squared is equal to what? Which a is actually the hypotenuse. I hope you guys can see that a is the hypotenuse. So a is equal to 8 squared plus x squared, right? That's in triangle 2. So this is still Pythagoras. This is still Pythagoras. And what we need to do is, now we need to kind of like simplify this equation here and label it as equation 1. So b squared is equal to h squared, right? So if we break that down, that becomes x squared plus 2xc plus c squared. Okay, so this is, we'll label it as equation 1. And this one we don't need to simplify much. A squared is equal to h squared plus x squared, right? And that's just our equation 2, right? That's our equation 2. Now we're going to use elimination. We're just going to say, okay, equation 2 minus equation 1. All right, so a squared minus b squared, that's just a squared minus b squared. Nothing changes over there. Okay, that's on the left hand side. This is equal to 8 squared and a squared, they cancel out. X squared and x squared, they cancel out as well. And then we're left with what? Minus 2x c minus c squared. Okay, that's what we're left with. So what needs to happen now is we need to then get rid of the x over there. Okay, we get rid of the x, so we can rearrange the equation so that it looks nice and proper. So what I'm going to do is I'm going to take the c squared to the other side. All right, c squared to the other side, and then b squared must go to the other side. All right, so really the main aim here is to ensure that these squares don't have any negatives. Okay, these squares mustn't have negatives attached to them. So let's see what we can do. Yeah, so a squared plus, we take this one on that side, plus c squared, right, is equal to what? Might as well just take the minus 2xc to the other side. So 2xc is equal to what? So it's plus 2xc, because I mean, if the minus 2xc skips the equal sign, becomes plus 2xc. So, and then we take the minus b squared to the other side, so that becomes just b squared. Okay, so let's figure out how to, find the replacement for the x. Okay, because that definitely needs to go. So we're just gonna look at the triangle in which x belongs to. You can see that it's triangle 2, the smaller triangle. Okay, and we're going to express in such a way that we use cos as part of the trig ratios. In other words, we're going to tweak things a little bit. So x over a is equal to what? So x over a, and x is the adjacent for this triangle. Adjacent side, a is the hypotenuse, is equal to the cosine. But remember, the angle here, this angle here is just what? It's just b. So here it's going to be 180 degrees minus b. So 180 degrees minus b. Alright, 180 degrees minus b. And 180 degrees minus b, you guys know that that's in the second quadrant. So x is equal to minus a cosine of b. That's our x. So we need to go to that equation over there and substitute x. So then b squared is equal to a squared plus c squared, and then plus 2, right? And in place of the x, we substitute what? The expression that we got, which is minus a cosine of b, right? Minus a cosine of b, and then c. So this simplifies down to a squared plus c squared minus 2ac cosine of b. Cosine of b. I hope you guys can see that. Yeah. So that's how you prove the cosine rule, you guys. You can see it came out exactly how we solved last time when we were using the other type of triangle. But yeah, that's how you do the constructions and everything when you're dealing with this type of triangle. So let's redraw the triangle, because I believe it's very, very crucial when it comes to proving these things. So we'll just pen is refusing. We'll just prove area rule, because remember, once area rule is proven, so this we'll call A, this is going to be B, and then that's going to be C, and we are just going to do the constructions one more time. So remember, we said this is C, and that is little b, and that is little a, this is x, and that is the perpendicular. That is the perpendicular height. So to prove the cosine rule, I mean the area rule, this is going to be a little bit of a challenge. But look, finding the area of this triangle was not that tricky, right? So the base of the triangle is C, right? The base of the triangle is C, and the perpendicular height is just h. Do you understand? So now the area of this triangle is going to be 1/2. The base is C times h, which is the height. Okay, but we need to find the expression for the height in terms of the parameters within the triangle. Okay, yes, so we know for sure that h over a is going to be, right, h over a, that's opposite over hypotenuse, that's going to be the sine of something, the sine of this angle over there. But remember, if this is b, this is going to be 180 degrees minus b. So 180 degrees there minus b. And obviously that is just sine of b, because in the second quadrant sine is positive. Okay, so h is just the sine of b. So therefore the area becomes as follows: 1/2 C times the H, which is A sine B. Therefore, that's 1 over 2 AC, the sine of B. Okay, that's our area, you guys. And remember, this is another way of expressing the area, because each and every triangle has got the expressions for area, right? Remember what we said. You just say 1 over 2 and then you multiply adjacent sides, all right, 1 over 2 AC, and then the sine of the included angle. Okay, alternatively we could have said, okay, area is equal to 1 over 2 adjacent side, B and C are adjacent, so BC, and then what's the side between B and C? A. Also another expression, A and B are adjacent as well, so 1 over 2 A and B, the sine of the included angle. What's the included angle between A and B? That's just C. So we've got these expressions here. So this is what we call area 1, this is area 2, and then this is area 3. So we can equate all these areas. We can equate these areas. So let's see. Yeah, so we're just gonna say A2 is equal to A1, it's equal to A3. They're all equal, right? They're all equal because they are. It's just that now they are calculated in terms of different angles and all that. So A2, we know that's 1 over 2 AB, the sine of C, and A1, that's 1 over 2 BC, the sine of A, and last one, that's A3, 1 over 2 AC, the sine of B. All right, now we can do the pairing. Now we simplify that, and then afterwards we'll simplify that pair over there. Okay, so with a focus on the two pairs, you will realize that 1 over 2 is common, B is also common, so if we cancel things out, you'll realize that we're just left with A sine of C is equal to what? So A sine of C, and the B's are out, C sine of A. Okay, C sine of A. So this becomes what? We divide throughout by the product of the constants, so AC, AC. So that becomes sine C over C is equal to sine A over little a. Also, if we focused on the two pairs over there, you realize that 1 over 2, they cancel, and C is actually common, so we're just going to be left with B sine of A is equal to A sine of B, right? Then we divide by the product of the constants, so A and B, B falls off, so sine A over A, sine B over B, right? You can see that sine A over A, right, is equal to both sine B over B and sine C over C. So meaning that all of these are equal. So we just need to put sine C over them, and then to actually show you guys that all these three things are equal. Now you can rearrange these things, start with A, so that everything is in order. In fact, we were supposed to put sine C over C this side, so then it starts to show that it's actually sine rule. So yeah, I think we've done it, with this other triangle, all right? Because there's two kinds of triangles that you might encounter when you have to prove um, these type of rules. You know, there's the triangle with an obtuse angle, there's the triangle which has got, you know, acute angles. So yeah, they're not the same. So but I think we've tackled both, and you guys should be able to understand, you know, how to prove these rules in any case. And I think we've come to the end of the episode, and hopefully you guys enjoyed the lesson. And until next time, let's go.